Hello, thanks for joining this instance of the Antrea community meeting. And for today, we have two small topics to discuss. First, we are going to have Chan discussing how to implement egress in policy-only mode. And then we will have a conversation that we would like to have a conversation that will be led by Yang about a request that we received upstream for supporting except clauses in Antrea network policies. So let's start with egress. Chan, please go ahead.
Sure, thank you, Salvatore. Let me share my screen. I just prepared one slide, one page, to show the idea. This is for a request we received recently from users that they want to check whether egress can be used in other modes, traffic modes other than in-cap mode. The request is specific to network policy only mode, but I think this mode, this traffic model could be applied to no in-cap and hybrid mode as well. So this is what I did to explore this possibility. As you may know, currently our egress feature requires the traffic mode to be in-cap mode so that it can use the tunnel to encapsulate the port to external traffic. So in other modes, for example, no in-cap and network policy only mode, there is no Antrea tunnel will be created. So if we want to make egress in network policy only mode work, first we will need to ensure that this tunnel is created regardless of the traffic mode. Even the tunnel will not be used by port-to-port traffic. So during my experiment, I used Calico as the primary CNI and Antrea policy only mode as a secondary CNI. So this may look weird that the Calico CNI may already create a tunnel between nodes, but that will only be used for port-to-port traffic only. The reason why we cannot reuse the Calico tunnel to encap our port to external traffic is because it will require strong intervention with this CNI to be aware of its implementation and to be able to program this tunnel. And the IP tunnel is unlikely to support, to have the flexibility to encap the information we want to encode with the overlay traffic. For example, we use the destination IP. For now, we use destination IP. The overlay traffic, the destination IP of the overlay traffic, to represent the egress IP. The original, sorry, is the external IP where the traffic wants to access. But at least it doesn't seem obvious that there could be a way for us to program Calico tunnel to use that IP to be the destination of their in overlay traffic. So this is not a good option for us. So we will have to create our own tunnel, regardless of whether there is already one for port-to-port traffic. And this is the first step. And the senders, the open flow rules in the sender node only needs a few modification so that it can forward port to external traffic to go to the tunnel and to be forwarded to the egress node. And after that, we need to forward the traffic to the host network of the egress node and ensure it's is asnetted to the expected egress IP. However, there is a problem when this is with Calico because Calico leverages IP tables heavily and it ensures its own robustness by always ensuring the rules installed by Calico agent is always enforced first. And for such port to external traffic, the only the only requirement it will enforce as net is the IP is one of port IP. It doesn't have to be the local port IP. It just use a CIDR to check whether this is port IP. So even the source IP is a port on another node, it will also be asnetted by Calico's asnet rule. And so there's no chance for our egress IP tables rule get enforced. This is a problem with Calico CNI, and I guess there might be a solution to disable this behavior. For example, people may not want to make their port to external traffic get netted, always get netted. So I guess that might be an option in Calico to disable this default netting as net. But that will need some investigation. And after work around this issue, there is another issue that after we have the IP tables rule installed by Antrea agent to asnet traffic and send it to external. After the reply traffic will be forwarded to the egress node. This is expected. But after it is received by the host network stack of the egress node, by default, the routing table will determine that this traffic should be forwarded to the original node while the Calico's tunnel. This is because Calico has configured routing the normal routes to forward the traffic to the port IPs. Since this is the reply traffic of port to external, they will arrive at the node with the egress IP as the source IP and the port IP. The egress IP as the destination IP, and after denetted, it will use the port IP as the destination IP. So it will check the routing table and be routed by via this tunnel device. If we don't change the behavior, it will be dropped by the original node's network stack by two mechanisms. First, the RP filter check by default it is strict mode in most OS. So because the traffic should be received from this physical interface, but instead is received from the tunnel device. RP filter will drop this, strict mode will drop this. Even after we configure RP filter to loose mode or disabled, it was still dropped by invalid connection state. This rule is installed by default by kubeprocess or kubelet, and perhaps Calico will also install such rule to drop invalid connection. And so the two mechanisms will drop the traffic. Of course, they can be resolved by configuring API filter or and accepting traffic of invalid connection state, but I feel this may be not a very good solution. So another solution is that we change the behavior on the egress node by ensuring a symmetric path of the return traffic. This requires two changes in the data path. The first, we need to change the routing decision by enforcing policy routing. This is achieved by persisting the connection MAC. For example, when we send forward for the request traffic, when we send it to the host network from the OS pipeline, we will mark the traffic with a packet mark. And when we hand it in the host network, we could persist the mark to the connection mark of the connection. Then for the reply traffic, we could restore the connection mark to packet mark. Then we can enforce policy routing to say if the packet is marked, it means it's the reply traffic of egress traffic. We should consult another routing table instead of the default one. And in that egress specific routing table, we should ensure that if the packet will always go back to will be forwarded to the gateway device of Antrea OS bridge. So it will not go via the Calico tunnel. And after it reaches the OS pipeline, we have another problem to handle. It is because in net policy only mode, we don't even know how the port IP is distributed. And we have no idea where the port IP is. We don't have port CIDR in Node API to represent the port IP distribution. So one possibility is that we retrieve the port IP distribution while the Calico API or Calico specific annotation. But I think that would not be very generic and may need to adapt a different CNI solution, and there could even be a possibility that there is no public API to retrieve this information. And so another possibility is that we just get port IP distribution from the port API. But again, there's another problem, and this is what we want to avoid when implementing Antrea agent from the first day, is that we want to avoid retrieving the port API for all ports in the whole cluster, because that would cause a huge overhead to API server and will increase our memory usage a lot. So the third solution I have thought about is that we leverage OS pipeline to say that regardless of which tunnel we receive the regardless of which source IP of the tunnel we receive the in cap the overlay traffic, we ensure that the return traffic of the same connection will be forwarded to this tunnel using the original source IP as the destination IP. I haven't tried this learn flow, but I think it should work technically. And after this, the traffic could then be forwarded back to the original node via Antrea's tunnel, and it also ensures symmetric paths, and the whole data path could work in my test. In my test, I just installed a static flow to ensure that port to this IP will be forwarded via this tunnel. But in production, maybe learn flow is a viable solution. So finally, there is just one problem. Currently, I haven't sort of a good solution. Except for the SNet rule I just talking about, iCalicos iptables rule also enforce their rules in Mango table, which we will use to restore the connection map to packet map. So this is the same problem we need to resolve to ensure that our packet map restoring rule get enforced before Calicos rule. Yeah. I think for this problem, my plan is to check some Calico doc to see if there is some configuration to change the behavior or not to install these rules at all. If no such configurations, another possibility is maybe we could check whether NF tables could be used to change the order of the to ensure our rules to get enforced before Calicos once, because NF tables is another net filter mechanism to handle the packets. And I remember that IP tables rules gets a static priority in the net filter framework, and maybe we could use a higher priority by having NF tables rules, but that needs more investigation. Yeah, that's the findings and the problems I want to share with you. If you have any suggestions on this for this case, yeah, feel free to raise it and we can discuss here or well an issue later. Yeah, that's all from my side.
Thank you, Chan. So do you have questions, comments? And I think that, for me, I will need to re-listen to recording and wrap my head around this to get an opinion. I don't know if anybody has any question or comment for Chan. If so, please go ahead.
Hey Chan, does it matter if Calico runs in IP tables mode or in eBPF mode with respect to those roles you were mentioning?
If it runs eBPF mode, I'm not really sure whether it could even work because I'm not aware of what's the consequence when eBPF rules is enforced on the packets. Maybe we don't even get a chance to SNet the rule, the report to external traffic. But I'm not really sure. Yeah, I will need to check that combination.
Thanks.
I'm not sure whether when the traffic is forwarded from this to this, do we have a chance to make our iptables rules take effect? And especially when the reply traffic arrives here, is there a chance to use policy routing to ensure it's forwarded back to this device? I guess that would be more complicated. Okay, if there's no more questions, I think I can stop sharing and yeah.
That's good. We can move to the next topic, and which is about this request for a feature announcement that we have received. And the goal for Yang would be to discuss it with you to evaluate whether it's something that makes sense addressing or whether instead we should suggest the users for a different approach. Yang, please go ahead.
Thanks, Salvatore. I didn't prepare any slides for this, obviously, but I'll share my screen and talk about it so that we know that what this is about. So essentially, we received this thread from the Kubernetes Slack channel as well. And this particular user, I think, opened up 2 feature requests to be exact. And in my opinion, the 2 feature requests are very much connected because they all root from the same reason, being that the user is actually letting the developers in the cluster using the Antrea namespace network policies, whereas that we specifically said in the documentation that we envision those to be used by admins, same as the ACMPs. I'll touch upon that later, but to summarize the problem, in the current Kubernetes network policies, we have the ability to specify rules with IP blocks. And in these IP blocks, in the Kubernetes upstream network policies, there's a ability to add a couple of except clauses to these IP blocks, so that people can essentially poke holes in the IP blocks that they're referring to in the rules. Basically something like this. And we had a issue long ago, which is dated back to 2020. And the issue was about that we figured out in the upstream that the accept block doesn't really mean a allow, right? It means essentially a fall through, meaning that if there is a network policies that's allowing a specific CIDR, and then they poke a couple of holes using the accept clause, and if there's another network policy with a allow rule for that accepted clause, and the effect of this combination of rules will still be allowed because the accept clause doesn't sorry, I think I might describe this wrong. So let's try it again. So if we know that for the network policies, for the Kubernetes network policies, they don't have deny rules, right? So if they have a rule saying that I want to allow a pretty wide CIDR except for A and B and C, this means that everything in that CIDR except for A and B and C is definitely allowed. But what about A and B and C? Well, those are not hard denies. Those are just holes that poked in the CIDRs. And if there's another policy that's allowing the accepted CIDRs, it means by the end of the day, these accept blocks will be allowed rather than denied, because the previous accept clause doesn't really deny anything. It just poked holes in the CIDRs that it tried to allow. It created a lot of problems back then, even because for our implementation, it's really hard to do this hierarchical fall through. The only way we could have implemented it, and I think that's what we did by the end of the day, was that we needed to actually look at the entire IP block and look at these accept CIDRs and manually compute the resulting CIDRs after we extract those accept CIDRs from the original IP block and install all these addresses onto the OVS data path so that they do an exact match. The reason for that is there's not a really good fall through, quote unquote, support in the OVS data path, meaning that if we install some OVS flow on some priority, right now we don't have a action in the OVS flow to say if we hit this specific condition, let's jump to a lower priority flow in the same table, right? So we don't have that. And a couple years ago, we remember that we proposed this feature to the OVS team and was informed that it was a really, it was not an easy feature to support, to be developed, given that, there's a very specific use case we are proposing, and they decided that it wasn't really warranting a support for a feature such as, if we hit a conjunction, we jump to a lower priority flow. That's why the accept block was pretty hard to implement for the network policy. But since the network policy don't really have a lot of priorities among them, it was okay. And if we do encounter this accept blocks, we could just calculate the subtracted CIDRs and install them on the OVS flow. And another thing is that we explicitly didn't really want to do that for Antrea native policies because the Antrea native policies has priorities, right? So there could be rules that created at very different priorities. And if we also wanted to support accept, it will make a lot of rules. If people created, IP block rules with accepts at different priorities, it will make the data paths not really scalable because we needed to do a lot of computations. Plus, we thought that since we had all these priorities, these accepts will be able to admins obviously would be able to express these accepts in another way. For example, if we wanted to deny an IP block like this, right, and we want to accept these CIDRs from the bigger IP block, the admin could do two of the other things. One is they could put a allow rule on the top so that these blocks are actually allowed. B, admins can do something like we put these rules at a higher priority, but do a pass, which means that for these CIDRs, they are not denied by the underlying rules. For these CIDRs, we'll just pass to the namespace developers so that they can create Kubernetes network policies to decide whether they actually wanted to allow these accepted CIDRs. So we thought that, hey, we don't really need to accept, right? We have this tons of priorities. We have this path thing that we can delegate the decision to developers so that we don't have this problem anymore. Now, however, this user is creating this issue or this feature request saying that the problem for them roots from the fact that they actually don't let developers create native KMPs. They allow namespace developers to actually create AMPs only in application tier. So what they are wanting to do is still a fall through policy where the admin could write some rules and let's say for the IP block 0.0, and do a bunch of accepts so that these will fall through, and the AMPs in the application tier, which is created by developers, can have developer written rules, which determines what happens with these IPs. Now, we were advising the user saying that, well, we didn't really envision this to be a use case because we want these to be in our documentation. We want these to be a pass where the decisions of this are passed to the Kubernetes network policies, and they can create KMPs for this. Now, if the developers are actually creating ANNPs in the application tier instead, it will indeed be a problem because any rule that hits a pass will skip all following Antrea native policy evaluations and jump right to the network policy, Kubernetes network policy layer. Which means that if these accept blocks, if they created rules with a pass, any developer created AMPs in the application tier will not be evaluated anymore because they're still considered an Antrea native policy. So essentially, this is the problem, and we could so for this specific feature request, we could consider adding a accept block for the IP blocks in the Antrea native policy so that we support the quote unquote fall through behavior. But the catch for that is that we needed to introduce again these pretty confusing accept concept in the Antrea native policies, and anytime we have somebody write a rule like this, we really needed to carve out these accept blocks from the entire address space and for example, put up 30 something CIDRs in the obvious data path just to express what's the result of subtracting these accept CIDRs from the main IP block, which is not really scalable in my opinion. And another related issue also is how the same user talks about they wanted to have a not same label match or invert match for the same labels. Well, the same can go for the self namespace matching mechanism. They probably wanted the not self for the matching as well. Well, the reason we had was that because of the priorities and everything, I just talked about the past action. We thought the admins will be able to get away from not creating a not self or not same labels rule if they write the rule properly. But since again they're using ANNPs for developers in the application tier rather than the Kubernetes network policy, it means that the pass rules are basically not usable anymore. Then they wanted to then there are chances they wanted to create rules for, let's say, strict tenancy boundaries, and now they needed the not same label match because they want to be able to create a rule which says, hey, I wanted to drop anything that's not same label, right? And the problem with that again is the nature of data path implementation. It's going to be really non-scalable. And every time we have a not same label rule, we'll be needing to extract the IP addresses of pods that are not matching the same labels from the entire IP address space. And then every time a new pod is added or whatnot, the entire thing needs to be calculated again, and we needed to install all these big number of IPs in the OVS data path for the subtracted CIDRs from the original from the all the address space, which makes it it's not that hard in terms of implementation, in my opinion, but it will be a significant scalability issue or performance concern if it's not really used properly. So for these two issues, I wanted to get an opinion maybe in the community on whether we wanted to support it some way. I would say we definitely wanted to start by looking at the IP blocks, because the accept to IP block, although I think this is going to be really I don't know how to express this, but it will be a revert of a decision that we made a long ago for the Antrea native policies. But at least it would still be a very defined case. I shouldn't say defined. It will be a really small use case where I would not imagine people creating a ton of IP block rules with accepts. So it's probably going to be okay if we wanted to actually add an accept to the IP blocks. But for, let's say, the same labels, not same labels, it's gotta be a problem, because if there are tons of namespace in the cluster, and we create a really generic rule saying that, hey, any namespace that are not having the same labels with another namespace cannot talk to each other, then we can totally see the data path rules blow up because of a not same label match. If we actually calculate the address by subtracting the matching pods from the entire address space. So this is not going to be anywhere near a scalable solution. But yeah, that's essentially the two issues or the two feature requests that's submitted by the users. And I wanted to hear some community opinions or maybe even questions if I haven't explained the issue clearly.
It's perfectly explained to me. So yeah, I guess that we need exactly to decide on the points that you have discussed, and I'm curious to hear whether anyone has an opinion. Most importantly, the opinion that I would like to say is to address the user, whether to address the user's use case, we can do something that does not require implementing the accept block.
I remember that for Kubernetes net policies, because it still has accept field, and we already implement that, right?
We do.
So I imagine that if we want to add this support to Antrea native net policies, the only required change is to accept this field in API, and then try to use the same code block to enforce to subtract except from IP blocks.
Right.
Except for the performance concern, do you have other concerns that which may make this situation worse? If that's the only concern, I feel that this request is kind of makes sense because even a bit because the fact that we can only defer the decision of the policy to Kubernetes net policies, but we create our own net policies, and now there are also admin net policies. So I think requiring specific combination to enforce a specific to enforce a specific security requirement is kind of complex for users, and maybe this except field could really avoid this problem.
I think
Okay.
there's one thing,
Mm.
Chen, for the complexity question is that it's not related to performance, but I think in the API, the IP block type is shared between the network policy peers and between groups and cluster groups. But I think for the internal control plane API, which we use to send membership information and everything from the controller to the agents, I think it's a different representation for IP blocks for peers and for IP blocks in groups, cluster groups. So I think internally in the internal API, we support except for network policy peers, but I don't think we support except for the groups, and cluster groups. Someone should take a look and confirm, but I think when I looked at the user feature request originally, this is something I saw when I looked at the API definition.
Yeah, I think I would imagine that if we do wanted to add this change, we definitely needed to look at the groups as well and evaluate if it also makes sense to be added into the group.
Yeah, and I think if we regardless of whether we want to support it for groups or not, I think we'll end up having yes, if we want to support it for groups, then we'll have to end up modifying the control plane API. Yeah. Which is not a big deal in itself, right? Because it's internal API, and we've done that in the past, and we support this correctly for upgrades.
Yeah, it's not really a breaking change, right? It's just additional field, and I don't think. Let me think. In case of upgrade, wait a second. If an old agent doesn't know about the accept field, but the accept field is actually there. Oh, wait, sorry. Remind me again. In case of upgrade, do we upgrade
We ask that the controller be upgraded first, and the controller serves both versions of the API for a certain number of releases.
Okay. Yeah, probably need to think about it a little bit,
but I know we did that in the past, right? When
right, yeah. Mm-hmm.
we used, because we are at V1 beta 2 now. I know at some point we were at V1 beta 1 and we had to do something like this.
Okay. But sorry, go ahead.
Sorry, I'm not sure if I misunderstand. You mean the current control plane net policy object doesn't have except in the IP blocks?
No, let me share the link. I can put the link in the chat.
Maybe you could even share the screen if it.
I put a link if you want to open it. Yeah.
Yeah, sure. So wait.
Oh, I see. You are not talking about the IP blocks embodied in the net policy object itself. You're talking about what if user input except in groups.
Yeah,
right?
because in the user-facing API, in the CRD, right? In the CRD, we share the same type right now between groups and network policy peers. But I think when we translate it into the control plane API that we're looking at now, for some reason, I don't know why, but we end up not using the same representation. Here, I think we use a slice of IP prefixes, and if you click on the other link, Yang, which is for that shows the other link I put in the chat.
I see. I think that there are still two possibilities. One is that we support except in in net policy itself, not groups, then even though they share the same API object, we could still discard the except field when it is used in group context, and then this will not be a problem. And if we want to unify the experience that user can input except in both places, then this will need an update.
Yeah, I think we should unify because otherwise we have to reject it in validating webhook, and it seems that if there is no strong reason to do that, then we shouldn't do that.
So for the effective IP blocks, why was it called effective IP blocks then? I would imagine that if we could keep the API as is, we'll probably needed to compute the effective IP blocks for the groups. We need to compute it in the controller, whereas it seems like for the network policy, it's actually done at the agent level because we just pass this information to the agent, and the agent will do the calculation for the diff. So, but I need to dig into it a little bit deeper. I haven't thought closely about that issue. But on the higher level, we do think that the accept to the IP block in the policy or the group sounds like a reasonable ask.
Yeah, I think so, in my opinion,
Okay.
yes.
All right. But for the other one, I would say that I had a bigger concern, um, because of the potential of how these could blow up um in a big cluster. So think about the IP boxing. It's kind of like really static, right? So for any rule that has an IP block and a couple of accepts blocks, we know essentially what the resulting CIDRs will be, and those don't really actually change over time. But for this, if we wanted to support something like this, it's going to be really tough, because of the nature of essentially it's a similar request, except for the accept in that case will be the pods, and the pods will be changing all the time. And we have a big number of these rules because for each label sets we'll be creating the same rules, which is all going to be altering over time. And I think on the flip side of this is that this specific feature request will be much more harder to support in our current data path implementation, and that will indeed, in my opinion, cause a huge scalability issues if people started to write a cluster level rule with not same label matches. Um, so I don't know if you agree on this, and we should maybe uh, you know somehow push back a little bit on this. But as you were mentioning, right, because we do want it to support some sort of like fall throughs. This, to me, it sounds like from the use case perspective, it maybe makes sense, but from the implementation perspective, it's going to be really tricky for the current state of implementation in the Antrea native policies.
All right, the time is ticking also for today's meeting, so maybe it's time to summarize about this. So what should be our next step? Should we at least do an assessment of what it will take to implement this new feature, or is it something that we want to keep in the backlog and see if we get more user requests for this capability? or maybe we can say, okay, let's keep discussing over Slack, and then maybe we'll come up with an answer in the next few weeks. All right, I presume that silence here means that nobody has a very clear idea of what needs to be done here. So maybe, yeah, go ahead.
I have some personal feelings. I feel adding except to IP block is somewhat difficult for users to use without this capability and without combining with Kubernetes net policies. And this doesn't, it seems this at least, it seems doesn't take much effort to support this scenario. So I'm supporting this looks good to me. But for the other one, I feel it's just about simplicity of usage. And actually, even today, user could still achieve what they want by just using the Antrea native policies, right? It's just about duplication of the rules for different orgs. And could that org be really huge that it would become really boring to create so many policies? I doubt if it's really complex and hard to achieve by just duplicating the net policy, or maybe there is another way to facilitate the creation of such rules, the creation and the management. So, and it seems that on the other hand, we will take much more efforts to support that that kind of native support for not same label. So my personal suggestion is preference is to defer that request and see if this if someday maybe we could come up with another implementation or idea to how to address this specific namespace or org isolation requirement instead of making the implementation more complex. That's my personal feelings.
Thanks, John. Thanks for sharing this. And do we have any other opinion? All right. So I believe that it might be all for today. So, or do we have any final comment? Any other topic that you would like to quickly discuss? Waiting 5 more seconds. And that's all. Thanks everyone for joining, and talk to you in 2 weeks' time. Bye. Have a good one.
Thank you.
Thank you.
Bye.
Bye bye.